Good day, everybody. How was lunch? Great? Okay. So everybody's full, had dessert? Yes. Okay. Who is a developer? Okay. Who is an ops guy? Okay. Who does front-end? Who does not know what I've been talking about the last 3 sentences? Okay, perfect. Nice. Yeah, today code kills planet Earth. So I hope you all love your job. Still, maybe not after we finished. My name is Jan Timon Henne. I am this guy behind the truck. It's not mine, it's some truck I did a picture with. It's on Ibiza. And this is where I was last year while I was traveling a lot. I also DJ, I'm into electronic music. I travel a little bit more. This is me in New York, holding a bag of cronuts. I'm also an infrastructure engineer, so I do infrastructure as code on a freelance basis for various clients. But cronut, you say, what is that? So this is a cronut. Cronut is basically croissant dough made like a donut and deep fried. It's a typical US thing. After you've done this thing or prepared it in the morning, you have 12 hours to eat it. After it, you can just throw it away. It tastes like garbage. And I'm also some kind of an environmentalist. So I care about the planet and my CO2 footprint and stuff like that. And while doing that, I discover day by day new things that I can improve for myself to reduce the CO2 footprint. For example, I bought an electric skateboard to help me get to work instead of using a car or public transport. I try to eat as much veggies and fruits as I can, but I still love meat, and but I try to avoid it as much as I can. I recycle. I try to use wood instead of plastics, and try to avoid fossil fuels. I try to save energy where I can. So I'm pretty much one of the best persons who's living on planet Earth when it comes to CO2 footprint. So what can possibly go wrong? When I've heard about the test last year that you can measure your own CO2 footprint, you just go online. This site was in German, which I'll show you in a second, but there's obviously languages, all sorts of languages for those sites. And it can measure your CO2 footprint. And you're allowed to have like 2 tons of CO2 footprint per year to avoid climate change. This is what I got. So it's like roughly 30 tons. I think it's mostly related due to my travel activities, which is, for all the English-speaking people, this part. Also, I would have like 2.5 only with consuming my food, and like buying stuff like drones, electric skateboards, cars, I don't know. Sorry, try to avoid the noise. Okay. Can you hear me correct? Okay. So coming back to my mobility stuff and the flying and such, you can calculate, you remember the cronut? So the cronut, I brought it back from New York to Munich for my wife, and she found it delicious, but I found out afterwards that while traveling from A to B, it produced 4.7 tons of CO2, which is pretty sad. Coming back to this chart, what it doesn't show is the work part. So we have no measurement for work. And I thought to myself, wait, so the most time I spend all year long is working. So I should measure that as well. And this is pretty difficult as it turns out. You think about this idea and you start Googling. And as soon as you start to Google something, something magic happens. Everything you thought was good before is now cancer. happens with all the things. So let's take a look in small cancerous things that we have in our everyday work life. Let's start with email, for example. Simple, we all pretty much all think I use it. And if I write a simple email to my colleague Sven, I just produced 4 grams of CO2. Wow. And if I attach my favorite cat meme, then I produced 50 grams of CO2. Not too good. If I would have used no image and instant messaging instead, I would have used only, come on, 0.0114 grams of CO2. This is just a small example on how you could improve by using instant messaging over email. Also, some other mitigations for that would be don't spam. So for all the marketing people here, I know you love to send out like various emails throughout the week to your clients to get them back in the loop and to keep them as a hot customer. Don't do that. So just do it as limited as possible and as necessary as it should be. So I started to unsubscribe from all the various whatever I subscribe to. Stack Overflow News, something that I don't know how to Google or something like that. I try to avoid email alerts. So whoever worked in ops has maybe set up email alerting for servers that go crazy. And then suddenly you have this inbox with over 50,000 emails that you have never had a look into because you don't know what they're actually saying or you don't care. And you can just turn them off. Would save tons of CO2. You could use instant messaging like Slack or whatever tool you want. And you could send no media, for example, in footers and stuff like that. Or avoid attachments if possible. Don't send large documents, this and that. So much for a small part of what we deal with on an everyday basis when it comes to work. This is something now that is much bigger, like way, way bigger. Like this one thing is a server, and Amazon, AWS has 2 million of those. I will focus mainly on AWS because it's the biggest cloud provider, and the majority of my clients are using it. They consume lots of energy, of course, and to give you a scale, all data centers and computing power combined in the world is using roughly 10% of today's energy. It's bad, but it's not too bad, because the estimation for the next 6 years would be we double that to astonishing 20%, without taking into account that we have more IoT devices, cars, fridges, cats with tinfoil hats, I don't know, who will be connected to your smartphone or whatever. This is not taken into account in that study, so you can imagine how bad it will be. For example, Facebook is using the same amount of energy every year than Italy. The same goes for Netflix, for example. Let's look a few years back. So, amazingly to know, 2010, we were also using 10% of the energy of the world to power our data centers. Why has it not changed? Because we invented stuff like virtualization and containers, and we moved some stuff to the cloud, which is great. So we didn't double in the last 10 years, at least. What? Sorry. Okay. Sorry about that. Yeah. So the compute power in the world, so all the computational power is for 60% gathered in data centers, which is interesting because the server installation base of all the servers in the world combined is only 15%. So cloud usage is not that big of a deal right now. So most of the servers that we have installed are running in some basement on-premise, I don't know, and they have such a small amount of compute power, but they consume a vast amounts of energy. What does this mean? Actually, one does not simply set up efficient data centers. If you can do it better on-premise than Amazon, Google, Azure, who dedicate whole teams, they build their own hardware. They have whole teams who are looking at energy consumption. They build solar fields, wind fields. If you can do it better, go to them and get hired for like enormous amount of money. Saying that, cloud servers are 3 times more efficient. Why is that? Because they are constructed to be like this. For example, as I said, customized hardware. You can save 84% of your energy just by moving from on-premise to the cloud. I don't care if it's Amazon or any other provider or About You cloud. I don't get paid. And you cannot pull off some things they do. For example, Facebook. Facebook is building huge data centers in the Arctic Circle in Sweden. This is a picture of it. There's no better quality, sadly, except that one, and that's actually from the inside. I don't know what they're doing there, but it looks great. I would love to work there, actually. Microsoft is powering his Azure centers partially under the sea, in the ocean, to reduce the heat amount. And there are also concepts for underground data centers, just to use the coolness that you have at a certain level of deepness in the ground. Why is that? Why is your on-premise not as efficient as data centers that are specialized in having lots of customers? A study found that the average on-premise server that you buy is only used by roughly 15%. And of course, Amazon and people like cloud providers, they don't want to spend their money on something that's not used. So they build it like this. They have like 90% usage for their data, for their servers. Much more efficient and saves a lot of energy. So much for the infrastructure part. Let's come to backend. To improve on the backend side is actually not that hard. It's really easy. You could, for example, just upgrade from PHP 5 to 7, which is not a big deal. Of course, you have to rewrite some of your code, but actually, if you would do this for 50% of all the servers in the US, you would save 3,600 tons of CO2 every year. So easy. And you get all the security fixes as well. Now you say, ha, PHP, I do Java. Let's take a look. So this is basically a chart showing the efficiency and the energy efficiency for various groups of interest. And the lower your language is, the worse it gets. So actually C is pretty good. And who's doing PHP? Too bad, you should change your language. Maybe use Java instead. It's a little bit better, it's like in the middle. Or you can all migrate to Rust. Yay! So Rust is it's a pretty cool language, pretty new, I know, and maybe not too good for some use cases, but let's go Rust. Or C directly. Frontend, I got you covered. From the frontend aspect, we did one big thing which is really great, which was the first thing users got upset about, and this was Flash. Everybody hated Flash. You could not use it on your phone. On an iPhone, you could never use it, but this is a different talk. And the end user noticed the battery drainage as soon as you started a Flash page. So this was the first time actually we noticed the user doesn't want to have battery drainage. So why is it that today we outsource the major parts of our computing power to the end user? This is particularly bad if you consider this is a non-controlled environment. They could have used shitty hardware. They could like you have no control. In the server or in the data center, you have control. You can control these things. You can say, okay, my energy resource should be 100% renewable, no CO2 certificate trading stuff. You could say, I want to optimize my hardware for a certain logic that I need to perform for my business. That's all possible. That's not possible on the side from the consumer side. So maybe we can get all this computing power that we outsource to the client back to the backend. And also, we can collaborate, of course. Right now, I work with a lot of companies where there's the dev team, the ops team, the front-end team, the marketing team, and everybody's yelling DevOps. But nobody's actually sitting together, working together. And this is really, really crucial. All those people should work in one room, like the ops guy, like the backend girl, and like the front-end designer, or front-end coder, sorry. And what tools do we all share? It's like CI/CD. CI/CD is a really good tool. It's one tool which comes from the automation aspect. So automate all your processes, which is nice, so you can spend more time on important stuff. Right. And now that we all automated stuff, we need to make sure we don't over-deploy. I've seen so many setups where you deploy like too often unnecessary changes were deployed, or you didn't change a version, but you changed an image which you were baking with Ansible, but it had no changes, and you rotated like 400 instances on Amazon for no reason. Or sometimes we just do comment changes in the code, and you don't necessarily need to deploy that. Testing QA, you should consider if you're over-testing. Testing is great, and many customers that I have don't really test, but as soon as you have a certain level of testing, you should really think about it. Do I need to run all my test suites on like one small commit that I did? Or isn't it enough to do it on acceptance and test, or whatever you want to call your instance where you get all the stuff together for the first time before I ship it to production or whatever. The next thing is multistage. So we're in an age where it's simple to have a Docker container on your laptop, then maybe you have like 5 or 6 environments until you call it production. Do you really work on all those stages at all times, and have you scaled it right so you didn't overscale? Stuff like that. You could start considering this, or we should start considering this, because I too often see that money is spent on the wrong aspects, and time is spent on the wrong aspects, and we could shrink this after we automated so much to be more sustainable and more cost effective. And last but not least, recurring tasks. So I often see people having cron jobs, delivering some stuff like log files or triggering MySQL query, and with no sense, there's no output. So actually, there's a zero output action, which is not necessary, not only related to cron jobs, but like in general. You might say, oh, this sounds so bad. Don't be so negative. And you're right. Because, as I told you before, we could avoid the doubling of our energy consume in the last 10 years, and I think we can do it again by keeping an eye on those technologies that can help us share stuff together. We don't have to hold on to our precious infrastructure anymore. We can simply let go and share with everybody. So as nature takes over abandoned buildings, I think we can iterate and self-heal the same way. Like, automation will give us and gives us at the moment so much time to overthink processes and get back from a simple DBA job that we had like before and taking care of database backups and stuff like that. This is all sourced out and managed already. So we can get our head into the bigger picture. And this is actually what we all do on a daily basis. We just forgot about it. Cloud became a commodity, I think. And we just need to get ahead of the game again and do what we can best. This is our only solution at the moment, and I don't think we will invent something that gives us a plan B soon. Not in our lifetime. So it's time to think beyond the features and to overthink on-premise software choices. Do I really have to hold on to my precious old programming language, or can I move on for myself? Can I learn something new? Can I explore a new world? Do I have to stick to my deployment behaviors? And do I need to leverage the energy of my customers' devices so much? To rescue the next generation or the next and next generation or our childs to be developers as we are, and we did it in the past, it's in our DNA, we can pull it off. We are the most rapidly changing sector on the entire planet. We evolve more rapidly than any sector that we have seen so far. There's no car manufacturer that can do it better. There's no government that can do it better. There's no bakery or any other sector that can do it better. It's the IT sector who is running so fast nobody can catch us. We are technically the Avengers. Maybe that's a bit too high, but just need to do it. And just this week, a friend of mine, who is also a speaker at Code.talks, but don't want to be disclosed because he doesn't want to put his name on the tag, has founded what he's calling DevOps, Developers for Future, which is closely combined to the Friday for Future actions that are taking place right now. And if you want to participate, if you have some thoughts or ideas, you don't really need to work, like actually code, but it would be appreciated, of course. But I think ideas are valued the most. Then you could just go and join the Discord channel or follow them on Twitter or go to their website, which is really basic because, I mean, they started Tuesday. So let's get swifty, everybody, and do this. This is not for any of us. This is like for all of us. And yeah, thank you very much. I appreciate questions.
Wait, please. Where are you? Ah.
Hi. It's more a comment than a question. I'm Yannick. So first, thanks for your talk. It was cool.
Thanks.
I'm also a bit into sustainable energy and hosting a festival which has a focus on our environment. And you've talked about the CO2 figures that is produced by sending a cat meme. And I'm asking myself, where does this figure come from? and how does it compare to IM? So I personally think it's not a good excuse for being off the grid when you have a Slack client or a Rocket Chat client that's permanently open. And also, in fact, when you send a picture, the energy consumption is multiplied when everybody gets this picture.
That's true.
That's, yeah, not right for me. Also think that when you say, okay, now go learn a new language, how do you learn a language? You need to use a computer, and you need to migrate your code base. So it will produce, in fact, more energy than stick to the language you have at the moment. How do you think about this?
First of all, thanks for the comment. I explicitly excluded the image from the instant messaging example because I don't have a figure. So all figures I got are mostly on those two source links over here.
Yeah.
But there are various others that I simply cannot remember and could not show. But this is a good starting point. And if you Google like email CO2 footprint, then you will get the figures really easily. And you're right, if you send Giphies and GIFs and all that other stuff, also via instant messaging, it will be stored. But I have to say, for most instant messaging services that I've seen, you can just fire and forget because all those old messages get deleted at some point, and email mostly never does, as long as the company exists. And this is why I think the footprint of instant messaging, especially if we can just forget about the messages that we wrote 4 weeks ago, is really an improvement to email. The second question was
about the code base. You suggested that we migrate over to a new language that is better in the power consumption, but your team has to learn the language, and they start to learn it using the computers.
That's true.
We cannot use pen and paper or recycled pen and paper to learn it. And I think the energy overhead of doing this is way higher than using your existing code base.
Yeah, there's no such thing than zero waste or zero CO2 footprint. As soon as you have a living organism, you produce CO2, and I agree, this will consume CO2 in some way, either by having a laptop running or whatever. But if we look back at Flash, for example, and now it's, I think, HTML5, no? Something else? The front-end guys. Yeah, but I think that's a big improvement. Otherwise, we would still have Adobe Flash, and this is no big thing, I think.
Thank you.
Yep. Here.
Here, then.
Hi, thanks for the talk, especially for the first one ever. So
thanks.
And what I wanted to ask is, do you know Ecosia?
Yes.
Yeah. Okay. So I think that's also mentionable. So if you're using Google on a regular basis, the Ecosia is using Bing, but as the search, as the underlying search algorithm or search engine. But they have this, if you don't know it, they are planting trees for every, I think, 5 searches that you're doing on them. And that's actually, in general, I've seen a paper on that, in general, reducing the footprint overall, even though Google is also powering their data centers, I think, to like the biggest amount on solar energy. So that's also, I think, something you can do. Regarding the learning a new language thing, I think that's kind of like saying the production of an electric car costs more than just continuing to drive my gasoline car for the next 20 years. And then after 20 years, that's neutral, but you will continue driving your car longer than 20 years. So I think you have to estimate over a longer time how big the impact of what you're doing is. So of course, in short term, it will cost more energy to learn the new thing. But then if the general efficiency of what you're doing then is higher, it will it will average out or most likely get even better. Yeah, that's just what I thought on that.
Hey.
Hey.
Thank you for your presentation. And I really like the topic because it's a huge topic. And also your title is huge. Because to say code kills the planet it takes some courage to say it. So what I want to say is, did you research also how much energy saved actually written code which saved energy regarding process optimization, or the same point what he mentioned before is how much energy or coding energy goes into renewable energy? Do you have any research regarding that? Because in comparison, it's a part that I missed in your presentation.
I see, yeah, I get the point. Thanks. No, I don't have a concrete, a direct answer to that question. But what I can say is that we have so many aspects that we need to consider, like the internet opened up the world to via Instagram and such services to everybody. So I live in Munich, for example, and everybody's like traveling like crazy. So weekend trip to Bali, no problem. This is one thing. Then also we enabled a complete new market. Like you could possibly work from everywhere, but we don't do it yet. There's office sharing. We could possibly not live in like cities and produce a big CO2 footprint there, or we could like live outside somewhere, which would be maybe better. And all those questions go and create new questions and answers maybe. But this is like a really big thing to think about. And I truly think and believe that although I have no figures, we solved some problems and saved many amounts of energy. But also I think it creates new problems because we automate stuff. People get fired. It will be much worse in the next 10 years, and they want to be able to do something. They cannot code maybe because they're not able to in some way. And I think this will also lead to much more CO2 production because they need to do something, and I don't know what yet. So it's so difficult. It has so many aspects. I'm sorry, I cannot really answer it directly.
Thank you.
Okay.
So what I wanted to mention is that I see in a lot of projects that code is simply not optimized, and I think instead of switching the language, every one of you can go home and do some performance profiling and so on. And I've seen a lot of projects where you can reduce CPU power usage by 50% in just, let's say, 2 or 3 days. Of work. So I think maybe that's the right starting point to check out where you can really improve your code. You don't need to switch the language because that will make something like maybe 10%, and you can reduce by optimization like 50% of the power. And I think that's something everyone that is here listening now and want to do something can do right now and start doing it.
Appreciate it. Thanks. Yeah, all those things I mentioned are my personal thoughts. So and solutions. So they are more like suggestions. Those are not study results. Those are things that I came up with. So if you have any better ideas, please contribute, because I'm not smart enough to solve this problem at all. And I'm not a developer by myself. I only set up infrastructure, which is basically configuring stuff.
Hi. Thanks very much for the talk. It was very interesting. I think one of the aspects you can look at, especially for larger corporations, would be the cost savings that are achieved. So these sort of environmental issues were considered 10, sort of 15 years ago with corporate social responsibility projects. And much of that was driven through the cost savings that organizations could achieve by focusing on environmental impact and computing power impact, etc. So that's maybe something you could add to your presentation as well. One of the things, an organization I was working for at the time, one of the aspects that the technical director was focusing on was how much data was being duplicated between departments, and that was costing a huge amount of money to the corporation, but also the impact on storing all that data and caching and reusing stuff that didn't need to be cached and reused. So you could, for instance, just have a reference database instead of replicating data across many, many different parts of the organization just for the sake of having it in your current setup or your current system. Yeah.
Thanks. Okay. Appreciate it. So as I get to your question, just right away. I showed you that the amount of data stored or processed within cloud is like 15% just by now. And most German clients I have, they are not able to transition to cloud because they say, hey, it's evil. And also I want to keep on to my precious DBAs. I have 8 of them or 40, and they are managing backups the whole day. This is like political work, really much political work, and some even have systems where ZOS is still running, where there's no TLS, SSL encryption, stuff like that. So they're really not able to move. And this is something where we can definitely do something in the future and right now to help those and like digitalize. And as I always also told, we did it in the past, like we came up with smart things like containerization, virtualization, like stacking up services together and segregating them logically instead of physically. But thanks for the input, yeah.
Hey, thanks for your presentation. Just basically more kind of a suggestion or hint. We tend to only do things where we get charged for, in a sense of if someone charges us for machines, we try to save machines. So right now, no data center mostly don't charge energy consumption or don't have to pay for. So there's no Amazon bill for energy consumption. So if you spend the CPU, or basically if you idle the CPU and if you waste the CPU, it's the same amount of money at the end of the day. So I think this might have to change so that we start to think about how much we consume. Of course, at the end of the day, that would be just data centers or your own machines where you maybe get charged for consumption, maybe not, depends on your data center. And of course, at the end of the day, on the client machine, nobody cares about the snowflakes during Christmas time with the JavaScript. It's so expensive that, you know, your CPU is just heating up at the end of the day. But I think this might be one of the first steps to actually show a number, attach it, and make us pay for. In a sense of, you know, your cloud machine now is 50% cheaper if you don't spend the money on energy. So it's not basically a fixed price, it's just more kind of a consumption-based pricing.
Thanks. One really important thing before time runs out, if you really have to host anywhere on AWS or any other US also based cloud providers, please don't do it. Please host it as long as you can or as much as you can in the European zone, because the US mix of energy is horrible and the pricing there is horrible as well because they use all like 60% coal and stuff like that. So they charge you 10 cents per kilowatt hour, something like that, which is not possible in Germany. We pay 3 times as much. Thanks for the input. Right now, I wanted to close the talk with having the CO2 footprint attached to a single item, but because of the various factors which come down to in the end, do the people who invented the code actually drive to work by car or not? It's not possible at the moment to measure the exact amount of CO2 attached to one single item, which is being checked out in an e-commerce. It's not possible. I looked everywhere, and also you cannot easily track the amounts of energy which one process is using. This can only be done on some machines, and only if you have like Intel and AMD special access, and you can get the tools to measure this. But for cloud environments, almost impossible. Yeah.
Okay, we have a last question before we run out of time.
Okay.
To be honest, I'm kind of upset with your talk because code kills planet Earth. A mail against instant messaging is just a micro-optimization. Your cronut produced 5 tons of CO2 load in your talk, which means that this will be like 1 million mails. So what is the problem? Not the mail is the problem. Your cronut is the problem. Yeah. And I think our focus here is totally wrong. I think you're right. You're right with the meaning, with the opinion that we should optimize what we can, but the mail is not the starting point.
Okay. Yeah, 2 things. Obviously, the travel by myself produced 4.6 tons of CO2, not a cronut. This is, of course. But the thing is that this is what our profession is, and this sounds like critique, but it's not. It's a little bit like whataboutism. Like, what about a cronut? What about ships that driving on the ocean? Like, we should improve that, but we are not. I am not able to. I only have my work, and my profession lies within infrastructure. And I can only say, hey, I can optimize this shit. Like, I can do this, but I cannot build a freaking ship. And this is why I started this, and why I thought maybe it's a good starting point. And if other sectors start this as well, great. But I appreciate the critique. Yes. Thanks. Thank you.